All right, welcome to the quiz 2 solution. So this quiz is based on one-dimensional motion, so parts of chapter 1 and very briefly into chapter 2. So question 1 here, we are given some images related to some velocity vectors. So here we have a particle going some sort of acceleration from point 1 to point 2. So we want to figure out what the velocity vector looks like after point 2. So what we need to do is think about the direction of motion. So for the velocity and the acceleration, they are pointing in opposite directions. So that means that our vector needs to be shorter when we're at point 2. So with that, we know that option A is not going to be something. It looks a little bit longer, and if you go through and roughly measure it, it does turn out to be a longer vector. If we look at the vector for the acceleration, it is shorter than the vector for the velocity between point 1 and 2. And because the acceleration is smaller, that's going to indicate that we are not flipping directions, which means our only option for the answer is going to be B. So for vector 2 here that's given in B, it's shorter because the acceleration points in the opposite direction, so we're slowing down. But it's not we're not accelerating so hard that we've stopped and changed directions at point 2. So that is how we know it's B. So question 2 here is a little bit tricky. So you have, basically you're going 4 kilometers and then 4 additional kilometers. And in the 2 locations, you are going different, in this case, technically speed, because we're just moving in the one direction, or, the velocity is to the right. So for the first portion, we are going at 30 kilometers per hour. In the second portion, we are sped up and now we're going 50 kilometers per hour. So in both of these situations, it's the same trip, and we're being asked to find the average speed over the 8-kilometer trip. So what we need to do in this situation is think about the time. So I need to think about the first set of time, and I'm going to be leaving this in hours because my answers for A, B, and C are also in hours. So I don't want to convert to meters per second and then need to convert back to kilometers per hour. So my time, if we look at the definition of velocity, it's the change in position over the change in time. So this is our velocity in the x direction. To rearrange for time, we would have the change in position over that particular velocity. So I'm going to call this first set of motion, I'm going to call it 1, and the second set of motion 2. Just that way I don't need to come up with new variables. So my change in time for 1 is going to be 30 kilometers per hour divided by 4, or sorry, would help if I wrote that right. It's 4 kilometers divided by 30 kilometers per hour. We simply just need to plug this into a calculator. I got 0.1333 hours. I then need to do the same for time 2. And so I'm going to have, again, 4 kilometers divided by now 50 kilometers per hour, 0.08 hours. So the reason I'm doing this is now I have the entire time that I travel. I can just add time 1 and time 2 to each other, and this is going to help me solve for my total time. And if I go through and solve for the total time, I can then go back and calculate the average value for my velocity for the entirety of this time. So I'm going to have my displacement divided by my time. So I'm going to have 4 kilometers plus 4 kilometers, so 8 kilometers, plus 0.1333 hours plus 0.8 hours. If I take this and plug it in, I end up getting 37.5059 kilometers per hour. Now, last I checked, 37 is less than 40, so the answer would be C. So there's a couple of things we need to think about when doing this question. So first off, we can't just add our two velocities together and divide by 2. And the reason we can't use that in this case is we don't know how the acceleration works out. We don't know if we have a constant acceleration, and in fact we don't. We accelerate only at one point in our trip. Only at the end of 4 kilometers, we somehow instantly change our velocity from 30 to 50. So because our acceleration isn't constant here, we cannot just add the 2 and divide. And so that is what eliminates B. We spend more time going 50 or 30 kilometers per hour, so that is why A can't be the answer. We spend more time going slower. And then we were able to get an answer, so D cannot be the answer as well. So this is how you could go through and solve part C. It's okay if you didn't show any math and you just guessed and you got C. That is okay with doing this. However, hopefully when you did the problem solving question, that gave you a hint as to how to solve this if you hadn't. So let's go ahead and do that problem solving question. So for number 3, we're leaving our house. We're gonna go for a jog. We're gonna get about, and by getting out, we get 45 meters away before we are gonna turn around and come home because it starts to rain. So this is what is going on. So we've drawn a picture. We now want to go through and write out our variables. So I'm gonna have away from home. I'm going to call that away, and towards home, I'm just going to call it home. So I have a value for my speed when I run in the x direction away, and that is given as 5 kilometers per hour. Now here, all of my other distances are given in SI units, so it makes sense to go through and do my unit conversion. So I know that 1 hour is 60 minutes, and every minute is 30 seconds. Or it's not 30 seconds, it's 60 seconds, so that's 3,600 seconds. 1 kilometer is 1,000 meters. So I can go through and use this conversion, and I'm going to find that my speed or my velocity in the x direction away from my house is going to be 1.3889 meters per second. I then am given my value for my speed home. It's just 10 meters per second. You are sprinting out of your mind to run home because you don't want to get wet. So we have both of this information, and we know that the change in position both away and the change in position on the way home are the same, because we went 45 meters before we started coming home, which is 45 meters away from where we were. So both are 45 meters. So in part A, we are being asked for the total time, so the time we are outside running. And then for part B, we are finding the average velocity for the whole time. So let's go ahead and do part A. So again, our definition for velocity is given as the change in position over the change in time. So we can rearrange this to solve for the time. It's going to be the change in position over that particular velocity value. So let's look at away. So for running away, our position is 45 meters. For our velocity, again, we want to use the value that we have in meters per second. We do not want to round to 2 sig figs for our answer for our velocity here, because we want to make sure we're not accidentally rounding too soon. So we're going to use 1.3889 meters per second. And the time I got was 32.3997 seconds. So the reason I'm using such a high number of significant figures here in my answer away is just because I have 9s. Personally, when I have a 9 and it's going to round my answer too close to the number of sig figs I need at the end, I carry a couple of extra ones. Because in reality, I would probably not keep the 7 around if I was doing a normal question. But because that's going to round me, instead of rounding where I want to round, I'm going to round 2 sig figs sooner. I'm going to carry a couple extra digits. I now need to find the time home. Again, I'm running, sprinting 45 meters. I'm going to do this at 10 meters per second, so 4.5 seconds. So the total time is just going to be my 2 times added together. So 32.3997 seconds plus 4.5 seconds. I got 36.8997 seconds, or the total time I'm outside is approximately 37 seconds. So here we've used the relationship of velocity to go through and solve for the total amount of time we're outside. It's not a very long period of time. We chose a bad time to try to go for a run. But hey, we sprinted, we're home, we're mostly dry, who cares? In part B, we are being asked to solve for the average velocity for the entirety of the trip. So for the trip, if we think about it, we were home, we ran 45 meters away, and we came back home. So our displacement for the total trip is 0. I go, let's call it positive 45 meters, and then I switch and I go negative 45 meters. That adds up to 0. So our total displacement is 0. That means that our velocity for the entirety of the trip is going to be 0 meters per second. So you don't actually have to show any math for this as long as you say the displacement is 0, because we are starting and ending at the same point. That tells us that our velocity value would have to be 0. Now, something that's different between the velocity and the speed is speed focuses on distance. So in the previous video, or the previous question, right, we focused on, we were just going 8 kilometers. Here we know that we are going 45 meters and then 45 meters back. So we are measuring something different with the velocity here. All right, so that's going to wrap it up for the quiz solutions. If you have any questions, feel free to ask.